right, here we go. Question number 1 from our Precalculus homework number 12 in MyLab Math. We're going to start off with a Geogebra question. They want us to write parametric equations of an ellipse that passes through given points on a graph. So we're going to need to click this link to open our Geogebra window. And if you can tell by looking at these points, it appears that this would make an ellipse. Although it says write the equation of any parametric curve, we're going to use the fact that this is in the shape of an ellipse to come up with our parametric equations. So, if we go to our scratch work, we're going to be making use of two formulas that we have previously covered in the course. The standard form of an ellipse with a vertical major axis, that's one of the equations we're going to be using, and also the fact that we know this Pythagorean identity from trig, we're going to be making use of this as well. So if we look closely at these points that we're given, we're going to extrapolate three pieces of information. First of all, the location of the center of the ellipse. So we can see that this center is going to be at 2, -1. We also want to calculate the length of the major axis and the length of the minor axis. So going from -7 up to 5, that would be a total distance of 12. And then going across from -1 over to 5 would be a distance of 6. So let's record all of this information in our scratch work. Okay, so let's make sure that you understand what I have written here. We've got the center is the ordered pair 2, -1. The length of the major axis we calculated as 12. And the length of the minor axis we calculated as 6. So from this, we're going to need to then jump to our ellipse equation. And I would like to simplify this, knowing that since the numerator and the denominator are both squared, I can rewrite that as x minus h over b, the entire fraction squared. Likewise, for the second fraction, we can have y minus k over a quantity squared equal to 1. And then from this, I want you to notice the similarity to our Pythagorean identity, where this fraction could represent, well, this fraction, since it has an x, is going to actually have to be the cosine theta. Remember from our trig, we know that cosine theta is x, sine theta is y in the unit circle. So this fraction could be represented as cosine of theta, and this fraction could be represented as sine theta, and then we would have our Pythagorean identity. Cosine squared theta plus sine squared theta equals 1. All right, so all of this has been set up. This is the point where we're going to pull it all together and write our parametric equations. Knowing that we need to have, instead of theta, we need to have variables t for the angle. We're going to switch those thetas to t, and then we're going to write an equation. We know that cosine of t is going to equal x minus h over b. And we know sine of t equals y minus k over a. And now for some plug and play. Remember that the center of an ellipse is the ordered pair h comma k. So here we can see that h can be replaced with 2. K can be replaced with -1. And remember, minus a negative will make that a +1. Also recall, the length of the major axis is actually 2a. So if we divide both sides by 2, we can get a is 6. And the length of the minor axis is 2b. So dividing both sides by 2 will give me b is 3. And now I've got everything plugged in, and I can solve for x and y in these two equations. All right, here we go. Multiplying both sides by 3 to get rid of my fraction. That's going to give me x minus 2 equals 3 cosine t. And then if I move the minus 2 over, that will isolate the x. And we're going to write that with function notation. Because this is in terms of t, this would be x of t equals 3 cosine t plus 2. And for the sine equation, multiplying both sides by 6 gives us y plus 1 equals 6 sine of t. Moving the plus 1 over and now writing that in function notation, we're going to have 6 sine t minus 1, and we're done. These are our two parametric equations that should represent the ellipse. So back to our GeoGebra window. Our x of t was 3 cos cosine of t. You do need to move out of the parentheses to put your plus 2. And then we need to input y of t. And that was 6 sine, S-I-N, t, move out of the parenthesis, minus 1. And let's see how we did. Yeah. So, before you move on, please remember to click Save and Submit so that you update your progress in your MyLab Math. And that's going to do it for this particular problem. So if you have any questions or comments about anything covered in this video, please feel free to leave those in the comment section below, or you can text me. And thanks for watching.